Hi dear viewers, welcome back to the channel where we will break down the wires behind the world of technology. Today we are starting with one of unsung heroes of modern communication, the coaxial cable. You see them behind your TVs, running through walls and powering your internet. But have you ever stopped to wonder what's really going on inside these cables? Well, you are about to find out. From the way they are built to how do they carry data across cities, this series will uncover it all. So whether you are a tech enthusiast, a student or just a fan curious, hit that subscribe button and let's dive deep into the core of connectivity, starting with the coaxial cables. As previously mentioned that the guided media can be divided into three different categories. The first one is called twisted pair cable, the second category is called coaxial or coax cable, while the third category is called optical fiber or fiber optics. In this section we are going to discuss what is coaxial cable. A coaxial cable, often just called coax, you have probably seen one connecting your cable box, modem or satellite dish. It is called coaxial cable because it has multiple layers of materials that all share the same axis. It is a type of cable used to transmit signal for TV, internet and data communication. It has certain features like it is resistant to the electromagnetic interference, it can transmit data over long distances without much signal loss. Similarly, it is durable and long-lasting. Here is how it is built. In the center there is copper wire. This is the main path where the electrical signal travels. Around the wire there is an insulating layer to keep the signal from leaking out. Then comes a metallic shield, usually a braided wire or metal foil. This shield protects the signal from outside interference like noise from the electrical devices. Finally, there is outer plastic layer or jacket that keeps everything protected and holds it all together. Because of this design, coaxial cables are great at carrying high-frequency signal over long distance with very little loss. That is why they are often used for cable TV, internet connection and CCTV systems. Let's understand the working of coaxial cable. As we know, inside the coaxial cable there is a central copper conductor. This is where data flows. When data is sent, it is converted into electrical signals which then travel along the inner conductor. These signals move in the form of high-frequency alternating current carrying information like videos, audio or internet data. The outer metal shield which wraps around the insulator does not just protect, but it also acts as a ground. This creates a special channel where the signal travels in a confined space between the inner conductor and the outer conductor. This coaxial setup helps the signal stay strong and clean even over long distances. Think of it like this. The inner conductor is a smooth highway and the outer shield is the protective barrier that keeps noise, interference and traffic from disturbing the flow. Thanks to this design, the signal inside doesn't easily pick up the static or crosstalk from the nearby cables or electronics. In short, the coaxial cable transmits data using electric pulses along a protected path, fast, stable and with minimal distortion. That is why they are still used, especially in the home for cable TV and internet, where reliability matters most. Coaxial cables have long been used for television signal and early networking, but like any technology, they come up with few limitations. One of the main drawbacks is their bulky size and stiffness. Compared to the modern cables like UTP, coaxial cables are thicker and less flexible, making them harder to install and especially in the tight spaces or complex network setup. Another issue is their limited bandwidth. While coax can handle decent speeds, it doesn't come close to the what fiber optics or even advanced Ethernet cables can offer today, especially when it comes to supporting high-speed internet or large data transfer. Coaxial cables are also more prone to the signal degradation over long distances. Without amplifiers or repeaters, the signal weakens the farther it travels, which can lead to lower quality transmission and need for extra equipment. There is also a matter of noise and interference. While coaxial cables do have some shielding, but they are still not entirely immune to electromagnetic interference, especially in the environment with a lot of electronic equipment. Finally, the coaxial networks openly rely on shared bandwidth model, which means that as more users connect and use the network, the available bandwidth for each user decreases. This makes coaxial cable less efficient in high demand and multi-user environment. So, the coaxial cables are still useful in certain applications. It is important to be aware of these limitations when considering them for modern networking needs. When we talk about twisted pair cable, then it has single connector which is known as RJ45 connector. But when we talk about the coax or coaxial cable, then it is rich in connector. So now that we understand how cable works, let's talk about the essential component that bring it all together, the connector. Coaxial cable connectors are the parts that attach cable to devices like TVs, modem, routers, antennas and more. They ensure a secure connection and allow signal to transfer smoothly without loss or interference. There are several types of coaxial connector, but let's focus on the most common one. The first category is called F-type connector. This is the one you have probably seen on the back of your TV or cable modem. It is mostly used for cable TV, satellite, and internet connection. It has a threaded end which screws into place to ensure a tight and stable connection. The second category is called BNC connector, used commonly in the professional video, CCTV system, or radio frequency application. It features a quick twisted lock mechanism that provides a strong connection while allowing easy removal. The third category is called RCA connector, which are commonly used in older audio and video equipment. You will recognize it by its yellow tip for video and red and white for stereo audio. Though not as common today, but it was once a household standard. The last category in our discussion is the N-type connector. This is larger, more rugged connector, often used in industrial settings or outdoor antennas, where durability and weather resistance matter. And that's a wrap on the coaxial cable. Simple in design yet powerful in function. From TV signal to internet connection, they have been silently supporting our digital lives for the decade. Their layered architecture keeps data flowing smoothly, shielding it from interference and loss, a perfect blend of engineering and efficiency. Thanks for watching. If you found this video helpful, give it a like, share it with someone curious, and don't forget to subscribe for more tech related